My name is Rainer, and I'm an application engineer working in the local sales unit and OEM hub based in Mannheim, Germany. And I would like to share with you today, with a few minutes, a custom application, which we really like as well, one of our favorite, because there's a lot of ABB components inside. And even outside of motion, we are using sensors and also fuses from ABB. But I would like to use this opportunity to just present or focus on the motion products which we have here. Okay, so I would like to start with introducing this project, what it's about, and how it started, how it came to us, so that you all get an overview of what we're talking about. I see most of the people have never heard what a TBM slurry pumping is. That's good because I prepared a short description of the application. And also then we'll move on to the main challenges we face in slurry pumping, and then move on to have a bird's eye view of the ABB Motion package solution. And then to end the slideshow, I will have one slider on safety and protection of our components, and then there will be the end of the PowerPoint, which should take about 15 to 20 minutes. And then after that, we'll move into a live log-in session where we will log into the tunnel boring machine slurry pumping plant. And hopefully it will be active at this time, and if not, it's not a big deal. It's just about seeing our components, the AC500 and our frequency converters live in action, or at least alive. So let's get started. Who is the customer and what's the project about? Because of the rising demands of electricity needs and also the move from gas towards regenerative power like wind and photovoltaic, the state of Berlin has decided to expand the electricity infrastructure. And for this reason, they have awarded a project, it was first a bid, obviously, 3 years ago, to build a tunnel which is 7 kilometers in length. So starting from Teufelsbruck here, right up to Marzahn. Because of this, or when this project started, one of our existing OEM customers, who is a pump producer, so he's a component supplier, approached us with his idea of expanding his business from being a component supplier into a system provider as well. So selling a complete slurry pumping plant. And for this, of course, he needs more than just the pumps and the motors, which he has been already purchasing from us so far. So for the first time, he was interested in also using control technology from us. And so we were also welcome this idea a lot, and we said we need to support this customer with full force. And after speaking with our team leader and also our team members, we together decided that we shall bid together with this customer. So we offered him what we think would be the engineering costs from the ABB side and what the component costs are. And with this, he went into the bid and he won the project. And the main values I tried to put here on the left side, you can see why ABB was chosen is mainly because of the safety and security of our components, because this is a critical infrastructure project. And so we have the upper hand compared to many other manufacturers who can't produce certificates of security validation and stuff like that. And then, of course, we showed a lot of extensive experience in pumping application and specialized pump solutions, which also helped us a lot on winning this bid. And on the right side, you can see the products involved, only the motion products. So like I said earlier, also beyond motion products, we made sure that whatever ABB can offer, that ABB was inside. So the pressure sensor pumps, the flow sensor pumps, and a lot of other products are also from ABB in this project or in this slurry pumping plant. So let's move to the next slide, where we can have a small or a short look on what the application is about. So you can see here a tunnel boring machine inside the earth. And here, number one, let's start with this part here, is the cutting wheel. The cutting wheel is responsible for drilling the hole in the ground to prepare the tunnel. While this is being done, there is a lot of pressure coming in from below, from the groundwater. So the main duty, or the first duty for the slurry pumping plant, is to provide counter pressure so that the tunnel does not collapse. So this is done by pumping in betonite suspension here on top through 6. It comes in here, flows through the air bubble, which is creating counter pressure, and comes down here to 3, where you can see the betonite suspension built kind of like a small pool of betonite suspension. And during this drilling process, a lot of rocks and a lot of rubbish and earth and everything falls into this betonite suspension mixture here. And there is a stone crusher. This is all still part of the tunnel boring machine. So it's like a mix. So the tunnel boring machine's duty is to bore and drill the tunnel. And then comes our part, which is the slurry pumping, which then transports all of this material, which has been crushed and made small, back out of the tunnel and outside the tunnel. So that's the second part here, material transport. And outside the tunnel, there is a pool where all these rocks and dirt is then separated. It's called Separieranlage in German. These are then separated and recycled, and again, clean betonite water. So this is the third part, clean betonite suspension water is again pumped into the system. And this process is a continuous process which happens during the drilling process. This information and also this picture here was taken from the link below, Slurry Shield, about tunneling. So it's an open kind of a website from a university, from the European University of Tunneling, and you can get more information if you are interested on this site. And challenges in a slurry pumping plant. You can see one of the biggest challenges here is pumping 500 tons of material and circulating this every hour. So we have a lot of energy inside this small tunnel. So let me just try to explain so we have an idea of the specifications of this tunnel. The tunnel is 3 meters in diameter, so it's not very large. It's not for cars and trucks or railways to pass through. It is just to transport 380 kilovolts of electricity power through from A to B, right? So it's a small tunnel, and we have a lot of energy passing through this tunnel. So safety is really crucial at all times, because also the end customer, who's the construction builder, has mentioned to us that there has been accidents where the pipes just snapped open because the pumps did not stop when they were supposed to stop, and the pressure was increasing. And you can imagine 500 tons of material splashing through the tunnel. People can get injured if this happens. The pipe diameter of the slurry pumping plant is 200 millimeters. And the length of the feeding pipe is the one which brings in the clean betonite suspension towards the face of the pump or the face of the drilling machine to provide the counter pressure. And then another 7 kilometers back is the transport pipe length. So I'll just show it here in the picture so it's clear. So the blue one here, where I'm moving here in this direction, is the feeding pipe length going towards this direction. And then after it flows through the tunnel boring machine here, it is then collecting the rest of the stones and rest material through the transport pipe back into this separation pond, where it's then recycled, and the process is then starts from the beginning, and we are then pumping this in circles. Below here, I've also listed that the main duty is the tunnel boring machine driver tells the slurry pumping plant, create so much pressure as counter pressure, and the rest has to be done with the AC500. So the AC500 needs to know, okay, what's the pump length at the moment? How many pumps are activated at the moment? And try and regulate the PID controllers, which are built into the ACQ 580, and use all of this information to create the pressure needed at the face and at the same time avoid any kind of oscillations in the PID controllers inside the ACQ 580s. The static head of delivery and the viscosity. So the viscosity changes, yes, because we never know how much of rocks and what is inside the transport material. So it ranges between, so 1,300 is kilograms per cubic meter is pure bentonite suspension. And when you mix it with rocks and stuff, it goes up to 1,500 and 1,600 kilograms per cubic meter. Besides that, also the static head of delivery. So the pumps, the heights are also varying along the tunnel. The tunnel looks straight in this picture, but in reality, we always have a certain declination of the tunnel or an inclination depending on how they are drilling at the moment. So each and every pump has a height variation, and the distance between each pump is 1.5 kilometers. So we have a long distance between the pumps as well. So this is also one of the challenges in slurry pumping plants. Okay, so here we can see the ABB motion package solution. So let's take what we have now seen on the application side and see how we have solved this with ABB products. On the left side, you see the control room, or also the server room of the construction builder. And there he has his complete IT system, and he has set up using an IT partner complete fiber optics infrastructure, which is continuously laid out while the tunnel is being built. And there the AC500 is connected on using or let's start here first from the CPU side. So we have a PM5670 CPU, and together with the SM560S to perform the safety tasks, and a Profinet master coupler to communicate with the frequency converters and also the peripheral I/O devices. And this is done via Profinet ProfiSafe, which is connected to the fiber optic infrastructure. And then we also have port number 1, the embedded port, which we use for our engineering purposes, where we will then have a look in the live demonstration and log into the AC500 to see it in action. And we have the second port, which we use for direct access to the internet, which is important because our OEM pump manufacturer has requested us to use his smart sensor data, which he has attached on the pump, to control, detect, and avoid cavitation of the pumps. So that's what we have in the control room. And also we have a PC where the construction builder can access commissioning data and visualize what's going on in the slurry pumping plant. Inside the tunnel, we have, like I mentioned before, every 1.5 kilometers, we have a pump system from our pump manufacturer who builds this complete system, which includes his own pump with an ABB squirrel caged motor, with an ABB ACQ 580, and also peripheral I/O box, which duty is to receive emergency stop commands via mushrooms and also via ProfiSafe, and then switch off or stop the pump first in a controlled manner, and then go into safe torque off status. On the right side, we can see the tunnel boring machine itself, which is moving into the tunnel and drilling the hole. And there we have a CP600 panel, HMI, which helps the driver inside the tunnel have an overview of what's going on in the slurry pumping plant. And there you can see which pumps are activated, at what speeds they are running in, if there are any warnings or failures, and if anybody has pushed any emergency stop mushroom buttons and so on. So he has full diagnostic coverage, and also he has control via this panel. He can change the modes of the slurry pumping plant from automatic, half automatic they call it, and also in manual, complete manual mode. Also, while this tunnel is being drilled, I'm sure you're asking, how do they add the pumps, right? So once they've reached a certain deepness in the tunnel, they need to then stop drilling. So they have a bypass switch, which then connects, so to say, or closes the loop, so it does not go inside the drilling machine anymore. It's kind of like short-circuited before that. And what happens is this material is then pumped in a circle. And while this is done, they extend the pipelines into the tunnel, and they add the next pump. So the next pump, when it's added, it should be configured automatically, because the construction site team has no experience with frequency converters or commissioning them, or it does not have the time and capacity to spend hours in commissioning this frequency converter. So one of the challenges here is also that when a pump is added, only the safety bit is set by the user. So this has to be done because it's safety related. He will say, I have added pump number 6 in my tunnel system. Please activate this. So that's all he does. And the rest of the parameters for the control of the motor data, and all this other data is then sent via Profinet towards the converter. And the converter is then configured completely via the AC500. Here you see the potentiometers. This is the classical way of how slurry pumping is normally controlled. So it's not done fully automatic. This is like one of the first initiatives of making this complete automatic. So in the traditional way, the driver actually tunes each and every pump on his own. He sees all of the values shown in the CP600 and adjusts the pump speed as necessary in order to get the required phase pressure here at the tunnel boring machine. So this is already the last slide now. Just to have a look, what are the safety and protection functions which are important and installed in the slurry pumping plant. So from the safety side, across the tunnel, there are safety emergency stop mushroom buttons alongside the tunnel, and these are all connected to the fiber optic infrastructure in the tunnel. So that's where we have a strong point as well. Our ProfiSafe and Profinet can be connected via any kind of infrastructure. As long as it's Ethernet based, we can run Profinet and ProfiSafe on top of it. So there's also application notes you can find how we can run the AC500 safety protocols via 5G protocol, for example. And doesn't matter where this emergency stop button is pressed, the complete tunneling system, this 500 tons of material which is moving, is brought down safely to a stop status, and then the SDO is switched off or switched on the frequency converters, where the pumps are then in a safe torque off mode. Built into our ACQ 580, this helps us a lot in the time needed for commissioning and setting up the project. Features such as dry pump protection, pump cleaning, pump inlet and outlet protection, and also the built-in inlet PID pressure controller of the ACQ 580. All of this helps us a lot in the complete process of setting up this project. And the cavitation detection, as I mentioned earlier, is performed by the customer smart sensor. Although the ACQ 580 has a built-in feature, it was not really, or it's not so possible to measure the cavitation, because there's one point which you must take care. The frequency converter can only measure this if there's not so much of damping between the pump itself and the motor. So the vibration during cavitation must be detected by the motor or the motor torque in order for the converter to notice this. But it doesn't matter. In this case, we have the smart sensor, and then we can detect it via the smart sensor. Okay, so like I said earlier, now we can log into this tunnel boring machine. What's happening? What has happened so far? They've been drilling now since 1 year, so they've reached half of the 7 kilometers. They are at 3,600 meters right now. They drill 20 meters per day. So if they work half a day every day, they will need 2 years, and they are kind of like on time. So they are supposed to finish next year in summer with the drilling process. And now we're going to log into the network in Berlin using a VPN. where the end customer has given me access and also my colleagues here in the OEM hub, so that we can log into the system to provide support if necessary. And this was the case in once in a while when certain problems happen and the end customer can't diagnose the problem that quickly. So mainly the main causes of problems so far were all network based. So like pumps were going out and then the whole system goes into safe talk off, obviously, because that's the safe state. When a pump is not connected in the network anymore, the system has to go to think the worst and say, okay, I need to stop the whole system. So the whole system stands still, and then we get a call and say, hey, your system is not working. But in the end, it's just because one of the ports or the switches are not working well, and once they tuned their IT again, everything was working as before. Then we'll go to the second part where we will log into the AC500 and have a look at it live in action in Berlin, and hopefully we can see some pumping happening, like I mentioned earlier. Then we'll open up Drive Composer and also use Drive Composer to access the ACQ 580s directly. And finally, we can have a look at our CP600 visualization using a web browser functionality, right? Yeah, to save some time, I've already connected myself to the VPN network of the end customer with my credentials here, and we are using the SSL security profile. Okay. And here we have our AC automation builder. And let's see how this goes right now. I did not connect it yet today. Great, that went smooth. So we're in the system, and we can see now the AC500 is alive and active and has connection with pumps 1, 2, and 3. And I know that it's okay that pump 4 and 5 and 6 have no connection at the moment because these pumps have not been installed yet. So it's totally okay that they're not there. Everything is prepared. So once the boring process is already reached that status and the pump is connected, it will be automatically detected via the Profinet scan of the AC500 with a MAC address scan, and then the user at the tunnel tells the AC500 this is pump 1.4, and then it gets parameterized automatically. These are the transport pumps below, so 2.5, 2.6, 2.7, and 2.8 are installed, and the ones which have not been installed yet are 2.1, 2.2, 2.3, and 4, which will be also installed alongside the drilling process. So we can see here as well, we are around about halfway through in the drilling process. What else can we check out here? We can see here are all the pump instances. And I see here that the pump is not running at the moment. So that's a little bit unhappy at the moment for us. It would be nice if then we could have seen more values. But we see here the pressure values are always there, regardless if it's pumping or not. So the inlet pressure is measuring. These are all milliamp values. So it's all measuring round about 4,000 milliamps, 4,500 milliamps, and 8,400 milliamps. The scalings are all done the AC500. We can see the scaled values later when we log into the CP600. We'll just keep this running at the same time and have a look at Drive Composer. So in Drive Composer, we can see also all of the pumps. So here we see 1.1, 1.2, 1.3, and 1.4 is not here, obviously, because it's not plugged in yet. And the tunnel is halfway through. So we have half the number of pumps installed, which are 3 pumps, which are pumping the bentonite suspension inside the tunnel boring machine. And we have 1, 2, 3, 4 transporting pumps, which are transporting the material back out to the separation pond. And we need more pumps for the transporting, because transporting the material back is much harder work because the material density is higher. So we need more pumps pumping back. When we are done, we'll have in the end 6 pumps in this direction and 7 pumps back, transporting back the material to the separation pond. So this is a nice view in Drive Composer. It's also a built-in functionality. I'm sure a lot of you know about this functionality. If you click this this pumps on and do a right click, you can show this amplitude logger where you can also adjust which values you want to see. So the standard values are, we can see the output power and the output current. And it's kind of a histogram which shows along this whole year where this pump has been working most of the time. So if you look here at the output power, most of the time the pump has been working on between 50 and 60% load. And very, very seldom it worked even between 80 and 90%, and almost never at 100% of its load. So in this case, we went a number to be sure. We dimensioned the converter quite heavily high, and it's working most of the time at half mast. But we need to be aware at looking at these values, because this tunnel is also growing, and it'll be interesting to see these values once the tunnel is reaching the end. And also we have a lot of material being transported 7 kilometers backwards instead of now 3.5 kilometers. Okay, so here we can see the difference or see the similarity. All of the pumps are already configured in the AC500. As the tunnel is growing, the user plugs in the pumps one by one and does not have to do any parameterization or configuration. He just needs to activate this pump in the safety program, because this must be done manually and via a human being to avoid any kinds of safety issues. But he does not need to parameterize the pump. So it saves a lot of time on the customer side. Okay, now let me open the web browser and log into our CP600. Okay, so here we have like an overview in the panel, how it's installed inside the tunnel boring machine. And this is what the driver can see. I'm not going to click anywhere around here because I don't want to disturb anything in the system. So the user or the driver inside can switch between manual mode, which he is right now in. The pump has been stopped for some reason. Maybe they're having a break or doing taking some rest, and he can go into automatic mode or in half automatic mode. And we can see here the pressures of the pumps. Here is the inlet pressure, and this is the outlet pressure. So as you can see, pump number 1.1 is installed up above of the tunnel, and this is directly at the separation pool. So that's why the pressure is also very, very low up there. And pump 1.2 is already 28 meters underneath the earth at the tunnel beginning, and there you can see a pressure of 1.7 bars in the inlet. And of course, since the pumps are not pumping, there's not much pressure differences. But what we can notice here, which is also interesting, is you can see a difference here, because you can see the outside pump or the outlet pump pressure is 1.5 bars. But after 1.5 kilometers, the pressure has risen by 0.6 bars. This is only because the height is different. So pump 1.3 is much lower than pump 1.2. So that's the only reason the pressure is higher on this side. And then the outlet pressure is pretty much the same as the inlet pressure. This goes here. This pump, for some reason, is now out of the network. So that's why they're showing really bad values like -1. And if we can't get this pump shown in the network, then we just blank it out in the visualization. This helps also the driver see where the problem is and look for the problem and find it. This is the bypass switch, which I mentioned earlier, when they are adding pumps into the system. And as the user adds the pumps, these pumps will then be automatically popped up inside this display as well. And these are the transport pumps pumping back the material up into the separation pool. And here again, you can see that the last pump, which is inside, underneath in the tunnel, which is 28 meters below, which is trying to pump up the material back into the pool, and it has the highest pressure here. Okay, so that's about it from my side. Thank you very much. And let me see if there's any questions inside the chat. Yes, thank you, Annette. Yeah, there are people inside the tunnel while the machine is working. Yes, this is why safety is so important. Yeah. This is done by providing the, or maybe I can go back to the presentation where I have this picture. Just give me a second, or even better, open the website. So this is the website I was speaking about earlier. Okay, we can see this cross-sectional picture, right, which I had in the presentation earlier. And the slurry pumping plant provides counter pressure. So that's one way of making sure the tunnel does not collapse. And then, of course, it's very important as the hole is being drilled, the tunnel needs to be sealed directly. So you can see this in this part of the picture. There are segment erectors and segment conveyors. So these are cement rings which are then directly placed on the tunnel, and the whole hole is sealed with cement and beton, so steel and strong material, which is then securing the hole so that it does not collapse. I hope that answers the question.
Hi, Rainer. I have a question. So
Yeah.
how is technically, how is configuration being sent to the drive? Is it like you just used a standard Profinet library and send parameter by parameter, or is there some other way?
We use the drive write parameters library, which is inside Automation Builder, and write parameter by parameter. Yeah. In the end.
Okay. Good. Thank you.
Welcome.